Hello, you're welcome once again. Today we have this nice transcendental equation and we'll be solving for the value of x, right? So we have here 2 power x plus x. This is equal to 5. Now let's go ahead and solve for the value of x, right? Okay, now from here we have 2 raised to the power of x plus x. This is equal to 5, right? Okay, in our next step, let us move this x from the left hand side to the right hand side, and it will have opposite sign. So we have here 2 to the power of x. This will be equal to 5 minus x. Now in our next step, let us change the sides of this equation. So we can make the right hand side the left hand side, right? And we can make the right hand side we can make the right hand side the left hand side, yes, and we can make the right hand side the left hand side, but that will not affect the equation. So we have here 5 minus x is also same as 2 to the power of x. So we can see this is still the equation we have right over here, right? Okay, in our next step, let us divide both sides by 2 to the power of x, right? So here, divide here by 2 to the power of x. Divide here by 2 to the power of x. So here let us take note of this. 1 over a to the power of n. This is the general. This is the same as a to the power of negative n. So where this will be applicable is at the left hand side, but we need to write this left hand side so that we know where to apply this rule. So we have here in bracket 5 minus x. This will be multiplied by 1 over 2 to the power of x. Yes, exactly. That is what we have here. Then this will be equal to, this will divide this to 1, right? So now we can apply this law here. So this will become 5 minus x, then multiply by 2 to the power of negative x. This will be equal to 1. Okay, now in our next step, let us try making this power of 2 here equal with the coefficient of this right over here, which is 5 minus x. So we can see we have 2 to the power of negative x. Right over here we have a negative x. So let us think about the number we multiply to both sides of this equation so that we make this power exactly equal to 5 minus x. Since we know this law, that a to the power of m multiplied by a to the power of n, since they have the same base, so we need to sum the powers, right? So this will be m plus n. So therefore, the number we multiply, or let's call it the quantity we will multiply to both sides of this equation, must have a base of 2, so that we can add it to the power of this 2 here to make an equal coefficient with this here. So let's think about multiplying both sides by 2 to the power of 5, right? So let's multiply both sides by 2 to the power of 5. So here we have 5 minus x multiplied by 2 to the power of negative x, and here we multiply by 2 to the power of 5. This will be equal to 1 multiplied by 2 to the power of 5. So from here we have here 5 minus x. Now we sum these powers here, so we have 2 to the power of negative x plus 5. Then this will be equal to 2 to the power of 5. Okay, now next step, let us rewrite this. So negative 5 plus 5, negative x plus 5, is same as 5 minus x. So we can see we have obtained equal power and coefficient, right? So we have here 2 to the power of 5 minus x. Then this is equal to 2 to the power of 5. Now in our next step, let us take note of this. A can be written as 2 to the power of ln of a. When a has a power of b, so we can also express this as e to the power of b multiplied by the natural log of a. So here we can see that 2 here has a power of 5 minus x, so we can write it in this form. So this will be 5 minus x multiplied by, this will be e to the power of 5 minus x times the ln of the base, which is 2. This will be equal to 2 to the power of 5. Now let us recall the Lambert W function. Remember the Lambert W function with the following argument: x times e to the power of x, where the power of e and the coefficient are exactly equal. So this simplifies to x. So here we can't apply this at this moment because The power of E here and the coefficient are not yet equal. The only difference here is this ln of 2. So let's go ahead and multiply both sides by the ln of 2. So we have here 5 minus x multiplied by the ln of 2 times E raised to 5 minus x multiplied by the ln of 2. This will be equal to 2 to the power of 5 multiplied by the ln of 2. So we can see we have the same power and coefficient. So let's take the Lambert W function on both sides and equally take that at this right hand side. So with this property here, this will simplify to 5 minus x multiplied by the ln of 2. This will be equal to the W of 2 to the power of 5 times the ln of 2. So let's quickly divide both sides by the ln of 2. Divide here by the ln of 2. So this will cancel this. So from here we have 5 minus x. This is equal to the W of 2 to the power of 5 times the ln of 2 divided by the ln of 2. So from here, let's quickly solve for x, and x will be equal to, if 5 minus x will give us this, therefore x is also equal to 5 minus this, which is at the right hand side. So we have here 5 minus the W of 2 to the power of 5 times the ln of 2 divided by the ln of 2. So when I use my calculator, I found out that this has a nice approximation. So we have this approximately equal to 1.715 620 733 and 28, and this is the correct answer. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share. Bye bye.